Hello, this is Luke Noctegal, and I will be presenting topics 71 and 72 from Understanding Research Methods, an overview of the essentials. So let us begin with an introduction to the chi-square statistical test. The chi-square statistical test is the typical test of the null hypotheses for differences between observed and expected frequencies. It is pronounced chi versus chai. Have had a lot of confusion about that myself. So anyway, the chi-square test is derived from the Greek letter chi, where the symbol x to the second power is used to represent this statistic within formulas and results. This is used for nominal variables. And here is a lovely image that I obtained of the chi-square formula from the folks at Statistics How To, the website. This is a great resource for all of your statistics needs, by the way. Recommended. And here you can see an example of what a chi-square test might look like. I also got this online from Stack Exchange. There was a forum on there that was pertaining to statistics. A very important question that the chi-square formula answers is variation in collected data due to chance or due to variables being tested. This ties in well to the null hypothesis that determines whether or not observable differences have been created by random sampling errors or strictly due to chance. Degrees of freedom. Values that reflect significance are dependent upon the degrees of freedom. Can be thought of as the number of pieces of information had within a chi-square test. This can be equal to the number of categories minus 1. The way I understood this was the final category being easily determined by calculating the sum of all categories prior, and that way we would know what the final category would need to be. Value of significance and degrees of freedom continued. Minimum value of significance at different p-values and degrees of freedom is indicated by comparing calculated chi-square values to another table of values. Here's an example of this within our text. When degrees of freedom increase, or the numbers of categories that are increasing, the chi-square value of significance also increases. Chi-square and degrees of freedom are not descriptive statistics. These go beyond what a typical consumer of research would likely to even be able to interpret. Instead, these should be thought of as sub-steps in the mathematical procedure for obtaining the value of p. It's important to remember that p has to be equal to less than 0.05 in order to reject the null hypothesis. Univariate analysis is how each participant is classified in only one way, whereas bivariate analysis is where each participant is classified in terms of two variables so that the relationship between them can be examined. A type 1 error is made when the null hypothesis is rejected when actually it is correct. Even when a null hypothesis is rejected at exactly the 0.05 level, which we discussed earlier, there are still 5 chances in 100 that the null hypothesis is correct. And then we have the type 2 error, which is the inverse of the type 1 error. It is when there is a failure to reject the null hypothesis, when in reality, it is the incorrect hypothesis. And using what we have learned about the chi-square test, we as researchers need to use probabilities to make decisions. We can never be certain about decisions based on observed differences. We must instead use probabilities to make decisions that minimize the likelihood that errors are made. The probability of a type 1 error is generally minimized by using a low probability of 0.05 or less. When using a low probability, we will make infrequent errors. when rejecting the null hypothesis. And lastly, we're going to conclude with the sources that I used throughout this presentation. I sincerely hope that this presentation is beneficial to your studies, and I wish us all the best of luck going forward. Tschüss.